Welcome everyone. We are going to look at Module 2, Homework 5. So Module 2, Homework 5 is about these exponent rules that you will need to know. I'm not going to go over each rule individually. We'll just go over them as we need them. So we're going to do some problems. The first one is x to the 10th over x to the 7th. You will notice that this rule looks similar to this. This is saying you have something raised to a power on top of a fraction. You have the same exact thing, but it's raised to a different power on the bottom. And it says the answer is what you get by subtracting the two powers in the order top power minus bottom power. So this is equal to the exact same thing we have on both of them, where the power comes from the top power minus the bottom power, and the order of that matters, and so the answer is x to the 8th. Another way to look at that is this. X to the 10th over x to the 2nd is x times 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 one more x, that's 10 x's, over 2 x's. And when you cancel out the 2 x's, what are you left with? 8 x's. That is why the answer is what it is, but we don't want to have to write that out every time, so we learn the rule. Okay, the next one we've got, number 2, is this. So the first thing we'll do is multiply all the numbers together. We get 2 times 5 times 8, and that is 80. Then we have the x's. We have x to the 3rd times x to the 4th times x to the w. Now, if you look at this rule right here, that tells you how you multiply things together that have different powers. And the rule says you add up the powers. So this is equal to x to the 3 plus 4 plus w. And that's equal to x to the 7 plus w, or w plus 7. But don't forget, we also had 80 multiplied by that in the beginning. So the final answer is 80 x to the w plus 7. Okay, this one here, there are various rules I can use, but I'm going to use the following rule. I'm going to use rule number 10, which says if you have a fraction raised to a negative power, you can flip the fraction upside down and change the power to a positive. So that's what I'm going to do. I have a fraction raised to a negative power, so I will flip the fraction upside down, so it now becomes r over k, and then it's raised to the positive power. But I can do more. Let me go back. I'm going to use this rule that says if you have a fraction all raised to a single power, you can put the power on each part individually. So I'll pop the power onto each part individually, which gives me r to the 3rd over k to the 3rd, and that is my answer. Okay, the next one. I'm going to use this rule over here, but you've got to be careful. This is a very important point I'm about to make. An exponent only applies to the thing it touches. So, this rule says if you have in the numerator a negative power, you can put it in the denominator as a positive. It also says if you have the denominator in the denominator as a negative power, you can put it into the numerator as a positive. So you can move it to the other part of the fraction and change the sign when you have a power. So, I'm going to move this. That's going to be going the bottom as b to the 3rd. I'm going to move this. It's going to go in the top as w to the 4th. Now what happens to the 5 and the 7? Well, the power wasn't touching those, so the power does not apply to those, so those stay where they are. And this is my answer. Okay, this next one here. This next one here on the numerator is kind of a couple different rules combined, so I'm going to just tell you how to do it. When you have something that looks like this, you just multiply the power by each of the individual parts. So we get x to the 8th and y to the 20th. The denominator is x to the 3rd, y to the 9th, but we're still not done, because now we can go back and use the first rule we did today, which says when you have something like that, you can subtract powers, so that gives me x to the 5th, and you can subtract powers, that gives me y to the 11th. So that is my final answer for that one. Okay, this one here, there's a couple ways to start, but I guess I'll start this way. It's similar to this rule, where you can take the power on the outside and just put it on each part. So that becomes x to the 5th, and on the bottom we have the y to the 3rd, and we're also raising that to the 5th. The numerator stays x to the 5th. The denominator, we're going to use the following rule. Let me go backwards. We're going to use the rule that says what happens if you have something raised to a power and you further raise it to a power, and the rule is to multiply the powers. So I need to multiply the powers in the denominator, and 3 times 5 is going to give me 15, and that is the answer. Okay, number 7. Give me 1 second before I do number 7. Just want to push things a little bit over here. I want to give myself some room. Okay, number 7 involves a lot of rules. One thing you have to be very careful with is only use one rule at a time. So I'm going to start with the rule that says if you have a fraction raised to a negative power, you can flip the fraction. So I'm going to flip the fraction. I'm not going to change anything about it except to flip it. Everything will stay exactly as it is, and that you need to be very careful to do that. I'm going to flip the fraction exactly as it is, and the rule is you then change it to a positive power. Then I'm going to use the rule I told you about, which is I can put the power of 3 on each one of these things. So that's going to become z to the negative 7 to the 3rd over x to the negative 2 to the 3rd and y to the 3rd. Over here, I'm going to use the rule that we used just recently. When you have something raised to a power, and that's further raised to a power, and that's what we have going on here, the rule is that you multiply the powers. So that will be z to the negative 21. Likewise, you'll multiply the powers, so x to the negative 6, and you're going to have y to the 3. We are still not done. As a general rule, you do not leave negative powers in your answer. But we had a rule that said if something has a negative power, you can move it to the other part of the fraction to make the power positive. So I'm going to leave the y to the 3rd alone because that's already positive. I'm going to take this thing with the negative power, put it on the other part of the fraction and make it positive. That's a 21. I'm going to take this thing to the negative power, put it on the other side, make it positive. That's 6. That's 6. And that is my final answer. X to the 6th over z to the 2nd, z to the 21st, y to the 3rd. Let me write that a little bit better. 21. Okay, the last one may look very complicated, but it turns out to be easy. One of the rules up above, maybe I'll find it in a moment, says that anything whatsoever raised to the power of 0 is 1. So the answer is 1. There's nothing more to do. Let me scroll back. That's the rule I'm referring to. Anything at all raised to the power of 0 is equal to 1. Okay, so that is Module 2, Homework 5. We're also going to look at the second part of Module 2, Homework 5. So I think you should pause the video and read this carefully and then restart the video. So if you read that carefully, you will know that this is in scientific notation, this is in scientific notation, and so is this. So what does scientific notation require? Well, it requires the number in front to be a number so that the decimal in front of it has a single digit number and not 0. So it can be anything point something, but it can't start with 0. It can't be 0 point something. And the first digit, like this one right here, has to be a single digit in front of the decimal point, but not 0. So that's not scientific notation. This is not scientific notation for a similar reason. In front of the decimal point can only be one digit, and here we have 2 digits. So that's why that's not scientific notation. The rest of all of these have a single digit in front of the decimal point. If you look at this one here, that's the same as saying 7.0 times 10 to the negative 12, and so that's why that's also acceptable. Okay, take a moment and read number 2 here. So when you're doing your homework, if you're writing scientific notation, something like this, your homework might give you an X to click on that goes right here. If it does, use their X. Don't do the X on the keyboard, because sometimes the X on the keyboard, it will misunderstand that and mark you wrong. Okay, number 3 here. We're going to take this and write this in standard notation. I'm going to show you the usual trick for doing that. So if you multiply, if you have something in scientific notation, and if the power is positive, the way you rewrite it, what that really means is you write down the decimal, you find where that decimal point is, and you move it that many places to the right. So 1, 2, 3, 4, 5, 6, 7, 8. Wherever you end up, that's where your decimal point will go. And any of these little things that don't have anything in them, you put zeros in them. And the answer is kind of what I have written. The answer is 6, 4, and then 1, 2, 3, 4, 5, 6, 7 zeros. That is the final answer. If I do the usual commas between every 3, that's 640 million. So that's what 6.4 times 10 to the 8th is, 640 million. Notice that when my exponent is a positive number, then that thing that I'm given is really something big. So big exponents, positive exponents in scientific notation give me large numbers. Okay, we're going to do this one in a similar way, but when the exponent is negative, the rule is you move the decimal point back. So we take our 3.27 and we go back 1, 2, 3, 4, 5. That's where the decimal point ends. All these empty spots we put zeros in. And so that is equal to 0.1234 zeros, and then 327. And it's somewhat common when you're writing a decimal, if there's nothing in front of the decimal point, just to put a 0 there. So that is the answer. This is a very small number, and notice very small numbers come from having a negative power. So the negative power gives you small numbers. Okay, let's go further. So what we just discussed a moment ago, a big number will have a positive exponent in scientific notation, and a small number will have a negative exponent. We need to know this for some things we're going to do. Let's move on. I think we're going to just skip that, and we're just going to go on and do things. So now we're going to write this in scientific notation. Here's how I'm going to do it. The first thing I'm going to do is figure out where the decimal point currently is. Well, that's 48,200, which is the same as saying 42,800.0. So there's where my decimal point currently is. Remember, scientific notation needs to have only one digit in front of the decimal point. So I'm going to move this until it gives me only one digit in front of the decimal point. So my answer is 4.2800 something. Now I got to figure out what I'm multiplying that by. Okay, it's going to be 10 to a power. Now you think about what we discussed earlier. Let me scroll back. We said earlier that a big number will come from having a positive exponent. Okay, what do I mean by that? Let's scroll down. Since this was a big number, the exponent is going to be positive. And how many places did we move? We had to move 4 places. 1, 2, 3, 4 places. So that will be a positive 4 there. So that is my answer, 4.2800 times 10 to the 4th. These extra zeros don't really do anything for us, so the answer that we need to write is 4.28 times 10 to the 4th. Okay, this is a small number. When you put a small number in scientific notation, your exponent will be negative, not positive, so keep that in mind. So we do kind of the same idea. We've got 0.002915. We're going to take that number. We're going to move the decimal point. So again, we'll end up with only one digit in front of the decimal point. So when I move that, I go 1, 2, 3 places. That makes it so there's only one digit in front of the decimal point. So the answer is 2.915 times 10 to a certain power. I moved 3 places. But remember, a small number has a negative power in scientific notation, so that becomes a negative 3. If you want a rule, which I really would rather not give you, I would rather you just think about it the way I told you. But if you want a rule, when you are changing it from a regular number to scientific notation, if you're moving backwards, you will put a positive power, and if you're moving forwards, you will put a negative power. But I'd rather you think about it the other way that I told you. Okay, we have 2 more problems here. We're going to compute this. Well, this is 3 times 2.1 times 10 to the 15th times 10 to the negative 4. 3 times 2.1 is 6.1. And these, the way you multiply them is to use the rule we saw earlier that said a to the m times a to the n is a to the m plus n. In other words, you add the exponents. So our exponent is going to become 10 to the 15 plus negative 4. And so our final answer is 6.1 times, too many 10s in there, 15 plus negative 4. Our answer is going to be 6.1 times 10 to the 11th power. That's the answer to the first one. Okay, let's do the second one now. To do the second one, I'm going to kind of split this up. This becomes 25 over 5 times 10 to the negative 8 over 10 to the 3rd. 25 over 5 is 5. And this becomes 10 to a power. And this is similar to the very first thing we did. Let me go back and show you the first thing that we looked at. What we looked at earlier was this rule right here. If you have something to a power over something else to a power, you subtract the top power minus the bottom power. So let's go to where we just came from. So this is equal to the top power minus the bottom power. So that is 5 times 10 to the negative 11th, and that is your answer. And that is the end of this recording.